Hi everyone, welcome. I'm Inessa Pawson, Open Source Program Manager at OpenTeams and Head of Open Source Architect Community, the host of today's event. The OSA community connects software architects and seasoned technical leaders who are passionate about open source technology. To learn more about the community, visit our webpage, openteams.com, openteams-communities, and you don't have to memorize the link. I will put a link in the chat shortly. And a few words about the sponsor of the OSA community, OpenTeams. We are the global technology leader in open SaaS, AI, machine learning, and data science. We bridge the gap between enterprises and open source projects behind the cutting edge AI ML technologies, facilitating collaboration, adoption, and optimization. And on to the topic of today's event. In the early days of the Western expansion of the United States, it took planning, perseverance, teamwork, and vigilance to survive. The same holds true for keeping your software stack secure. So for our June OSA Community Public event, I've invited Dave Ferguson and Kadi McKean from ReversingLabs to share their frontier-hardened wisdom on how to prevent and survive supply chain attacks. And with that, Kadi and Dan, please take it away.
Thank you, Inessa, and thank you so much for having us here today. I'm really excited. I was flattered when you guys reached out. So let's kick this off. My name's Kadi McKean. I'm a community manager at ReversingLabs. I run our open source community. So for any of you at home who might be an open source maintainer, please feel free to reach out to me on LinkedIn. I'd love to hear more about what you're doing and how we can possibly help you, because we do have community resources available for you. When I'm not at ReversingLabs, I do host my own podcast called 10X Insights. I'm a Penn Stater, proud of it. I bleed blue and white, and I'm also a co-organizer for DevOps Days DC.
Hi, everyone. I'm Dave Ferguson. I'm a director of product management here at Reversing Labs. Thanks for having us as a guest today. I appreciate it a lot. As it states, for myself, besides being kind of an application security, cybersecurity person, I'm also a burger enthusiast, Kansas Jayhawk. I've been in application security, cybersecurity for more than 20 years now, but I did start my career as a developer. Um, but Which has actually helped me in the world of cybersecurity as it turns out how things have evolved over the years. Yeah, Reversing Labs, we're a cybersecurity products company, and we're happy to present today. And Katie, I'll kick it over to you to tell us a little bit more, tell everyone a little bit more about Reversing Labs.
Yeah, so we're a company, we're one of the most trusted companies in file and software security. So delivering trust and assurance across every digital asset that you rely on for business needs. We're really known for our binary-based malware analysis is what we're really known for. And we have a 27 petabyte data lake. So just think about that. That's massive. And we also host the largest threat repository. So we contribute a lot to the OpenSSF in their threat repository, and we're also in most of the Fortune 500 companies. But you guys aren't here to learn about that, so let's dive into the agenda. So as you can tell, this deck is very much a throwback to my childhood. So hopefully everybody is either has heard of Oregon Trail, the game from the 90s, or if you're not, maybe you have watched 1883, a Yellowstone spinoff where they are doing the Oregon Trail. But today we're going to go through Oregon Trail parallels between this and the SDLC, kind of what that gating process looks like, how cutting corners can really affect you, and kind of the hazard that you could fall into if you are cutting corners. Common deaths on the trail, we'll equate that to different types of attacks, and then sudden disaster scenarios and what you can do to prevent those. And then after that, we'll take some Q&A and closing questions. But for those of you who are on today, please feel free to raise your hand to ask questions in the chat. We love to make this as interactive as possible. Ooh, next. All right. So has anyone actually played Oregon Trail here? Raise of hand, no? All right. Has anyone seen 1883 or knows what the Oregon Trail is? Yes, I see William nodding. Okay, perfect. Thank you. So Oregon Trail was a 2,000-mile journey that people took, right? And in the game, it goes from Independence Missouri all the way out to the Winnet Valley out in Oregon. So it's 2,000 miles, rugged wilderness. And there's just so many different things that could happen, right? You could have dysentery, you could die of a snake bite, you could freeze to death, you could die of starvation. There's so many different things. So today, this is kind of where our story element is coming into play, where we're going to equate a lot of the software development lifecycle to this game. So in short, whenever you're taking a journey right like this, you really have to prepare, make sure you have all your gear, you have a plan in place, make sure you're making wise decisions, and you have the right tools available with you for the journey. Be great if I could. Yeah, there we go. So the trail we're actually talking about today, other than the map I just showed you, is the software development lifecycle. Many of you, I'm sure, are aware of this, probably have it tattooed in your brain, but this is the one we're using today for the game and the purposes of this talk. As you'll see, we do include things in this SDLC that we need to be thinking about. So whether that's patches, releases, external repositories, there's so many different things that encompass the life cycle of how we push out software today that you have to think of and stay on top of all the time. And as many of you know, it can be very overwhelming. So in the game, right, there's 3 different people that you could be, right? You could be a carpenter, a banker, a farmer. Each of these folks has very different jobs, very different resources available, and different motives in the game, right? So you might be inspired to do something a little different if you're a carpenter versus what a farmer does, right? And you have a different skill set. Much like the game, the players we're talking about today are developers, security professionals, and operations, right? So each of these 3 different groups of people have very different motivations in their jobs as to why they want to secure their software supply chain, right? Developers and what motivates them, right? Developers are all about pushing fast features. If they can ship out features faster, they're killing it. Security, if they can ship secure code and prevent vulnerabilities, they're acing their jobs. Whereas operations wants to make sure things are running smoothly and reliably the whole time. So there's different pieces of the software development lifecycle in there, but at the end, it's really all one thing. So remember this map I just showed you, right? If you look closely at the map and in the game, you actually had different checkpoints along the trail. So you might have gone hundreds of miles without seeing a single person, gone through reservations, still not seen a person, but you will eventually reach a fort. You might be able to replenish your supplies, or get new wildlife, or see a doctor, right, if you're sick. These checkpoints were really crucial to people who were on this trail because it helped keep them alive, a little bit safer too, because they were able to retool and supply what their needs were at that time. And really just do a quick health assessment of how they were doing on this journey. Maybe they need to stop for a few days because someone was sick, or maybe they're waiting for more food or tools, but it was a chance to regroup and evaluate how their journey's going. When we think about how this equates to today's trail, right, there are certain checkpoints and gating processes in the software development lifecycle where you're doing either testing that code for developers, right? You're doing a QA check, and then you might be having a code review, whether that's peer or from someone else or another organization, I should say. You're also doing security testing, right? To make sure you're constantly having secure code, whether that's through an analysis tool, static dynamic, or even doing malware analysis. You also want to make sure that once you get through those gates, you're consistently doing that on a repeatable basis, because once it's in production, you want to make sure it's continuing to run smoothly, right? You don't want any surprises popping up, because what if something happens, right? You might take a chance, you might not. But these gating processes actually help you to make sure you're not cutting corners. What this is showing here is that maybe you think you can cut a corner real quick, maybe miss that code review, but what's going to happen? It's kind of like a little ticking time bomb. In the game, you could take the chance to raft down the Columbia River, but it usually didn't end well. Your trail or your wagon usually tipped over. I mean, I didn't have a very high success rate in taking those shortcuts. Some people do, but it's a game of chance. And that's similar to what you're doing with development if you're cutting corners like that. Maybe you're skipping those steps, and what happens when your hygiene isn't probably cleanest on your open source packages. You're more susceptible to malware injections, misconfigured pipelines, and maybe even incomplete vulnerability tracking. And these are all things that will come to bite you later. So we're getting into some examples now where we can start to see some of these little hiccups. So anybody know what's wrong here with this picture I'm showing you? Got any idea why someone might add an extra Y to a package? I see William smiling. Any takers?
What do they call that kind of squatting? Typo squatting?
Yes. So people add those little extra characters because it happens, right? We're humans. Someone's got a fat finger a key, or it looks close enough, but I'm not really sure. So what happens is when you're not checking these packages, right, or verifying that they're up to policy within your company, up to your risk tolerance, you're going to accidentally download things like malware, like this cryptography package that looks close, but if you look closer, it's actually not there, right? And there's many examples of that. So Dave, why don't you tell us about your fun little request package?
Yeah, so another example of typo squatting we have here, but the reason we're showing this one is Katie and I last month were at the PyCon show in Pittsburgh, and we were showing off some of our free tools, including a screenshot here from our, we'll talk more about this tool that we have later, but essentially it's a way to check out an open source package to see if it's safe to use or it has bad things in it, right? And Python, the request package is like one of the most popular Python packages out there. And I just tried to pull it up on our Spectre Assure community. I wasn't trying to show typo squatting. I accidentally, when I typed request in the bar at the top, I put an extra U when I was typing because I was at the show at a laptop and I wasn't on my normal laptop. So I just mistyped and I put an extra U. Instead of coming back with an error, this package is not found. I found out it's a real package that was on PyPI for a period of time. It's been taken down since there, but our Spectre Assure community still has it indexed, and so we see that it was there, and it was malicious. It was a purposefully done typo squatting attack that I accidentally demoed at PyCon last month. But it was kind of a happy accident, really. But another example of typo squatting I just wanted to pull up since it happened to me. Literally, it happened to me at PyCon.
You did see, I can verify, I did see him panic a little bit.
For a second, I thought the request package was malicious, and then I realized I typed an extra U. So, all right. So let me continue on here, Katie, with the pop quiz. Oh, you just gave away the answer.
Right.
That's okay. Um, does anybody remember December 2021? Now, if you're not in cybersecurity, you might not, but there was an event that happened in December 2021. Does anybody happen to remember what that was? Something in the news? Okay, you can move on, Katie. It was the Log4Shell vulnerability. So everyone may remember if you were working as a security person at an organization, you definitely remember. So Log4j is a heavily used open source Java library, for logging and whatnot. It had a nasty vulnerability, and it became known. It was so big it got a celebrity name, and it's called Log4Shell. And so what happened there? Well, back in 2013, some functionality was added to the Log4j library by guy was named Ralph Gors. And Ralph, he's not a nation state threat actor. implanting vulnerabilities with schemes to exploit it later. He was just an unassuming guy from the US, had some Java skills, and he liked to help the open source community. And so he contributed. But it turns out his commit back in 2013 ended up in an unmitigated disaster in 2021. So no one noticed the problem until 2021. But essentially, this vulnerability allowed remote and usually unauthenticated users to execute arbitrary code on the server. So mostly this was a problem with Java-based web apps. And it allowed anyone to execute code on the server. And that's about as bad as it gets. So we're talking about remote code execution vulnerability. In fact, it's one of the few CVEs that ever was given a CVSS score of 10, which is literally as bad as it gets. That's the highest as it goes on the severity scale. But yeah, it's super interesting that nobody noticed this vulnerability until 2021. And ultimately it was December, where a couple weeks before Christmas, that this was disclosed. And so everyone worked in security at that time, had a very bad Christmas and even into January. So it was really a scramble to find and fix that issue. So it was kind of the classic 0-day vulnerability where nobody knew it existed the day before, and suddenly the world was ending the next day. So that was a fun event. All right. So let me talk about another sort of danger in the SDLC. Whereas the other last one was more of a vulnerability. This was again a malicious, purposeful attack in an NPM package called UA parser JS. And now this was just like a month or so before Log4j. So it was like, I think November of 2021. And so this was a malware attack, targeted the Node.js community in this case. So very popular, heavily used package, UA parser JS. I mean, it was really a very small package. Its only purpose is really to parse the user agent string and HTTP requests. Right? But at that time, it was averaging around 7 million downloads per week. So very heavily used across the NPM community. And so the way the attack happened was the hacker got access to the maintainer's NPM account. They think through compromised credentials or credential stuffing, most likely, where the maintainer didn't have 2FA enabled on his account. And so he was probably using his credentials on another site, which got hacked, and then they were able to get into their NPM account that way. So the bad guy ended up publishing 3 compromised versions of this component. And these malware infected versions did really obnoxious things like installing crypto mining tools, stealing sensitive data from environment variables, trying to install system level malware for further infiltration. I mean, it was like a cornucopia of different bad things. So in this case, if you go to the next slide, Katie, in this case, the maintainer quickly fixed the issue, but again, with 7 million downloads a week, most likely hundreds of thousands of people got infected. And so the screenshot here is just kind of showing you, this is a screenshot from our supply chain security product, but there's essentially just 3 different versions of UA parser JS, starting at the bottom with a 7.28 version, and then the compromised version was 7.29, which I think you can pretty clearly tell with the red fail and the big red threats indicated. And then the maintainer fixed it in the 7.30 version because the threats turned green, right? So this goes to, and the dates you can see on the dates on the right. The compromised package was released on the 23rd, and the fixed package was released on the 28th. So that's 5 days. So most likely millions of times the compromised package was downloaded. So that's a compromise or a threat through the open source component scenario versus a vulnerability. So So yeah, back kind of to the CI/CD pipeline or the SDLC. When we're building software, there are all these different checkpoints, and trying to stay alive in the CI/CD pipeline trail is not that easy. And I mean, there are tools like Katie mentioned. There are different types of tools. There's static code analysis tools. There's dynamic scanning tools. There's software composition analysis or SCA tools. All of these things can help identify issues, mostly vulnerabilities, but they can identify other types of issues as well. Um, so they all report problems, but they can get very noisy and they can report many problems. So how do you kind of decipher the signal, find the signal versus the noise and all the findings? So in other words, how do you prioritize the issues that are found? Because these tests need to be done. You can't just release code without doing these types of automated tests with tools. So how do you prioritize? And you need to remediate the most critical issues first. So that prioritization effort is a constant battle. And with the Oregon Trail, where there are physical dangers, your risk of dying, right? So I think the rule of three comes into play here, meaning on the Oregon Trail, if you don't have air, you're gonna die in 3 seconds or 3 minutes. Excuse me, not 3 seconds. 3 minutes is your limit there. When it comes to water, you have 3 days. When it comes to food, you have about 3 weeks. So the rule of three there is how you prioritize in the physical world. With the software supply chain pipeline trail, it's more about obviously criticality of an issue. The CVSS score, like the log4j I mentioned, was a 10. That's like not having air. Then there's other issues that are more, say can exist for a while without being exploited. So being able to enhance the information through threat intelligence, like for example, if a vulnerability has an active exploit in the wild happening, and there's malware that takes advantage of that vulnerability, that should raise the priority of fixing that issue as well. So that's a prioritization effort that everyone has to do. Now, on the next slide, we're going to talk about kind of the analogies here between the game, dying of dysentery, snake bite, and whatnot that Katie mentioned earlier. What are the various attacks in the cyber world? Well, malware is the big one. We've talked about that, UA parser JS, vulnerability exploits like log4j. And then dependency confusion is a type of attack similar to typo squatting, but not exactly. Dependency confusion is about if an organization has an on-premise artifact repository, like say Artifactory or Nexus, and they have their open source developers pull open source components from that local repository. A dependency confusion attack is when an attacker makes a reference to a component that would not exist on the internal registry, and then by default it would pull from the internet, like say npm registry or PyPI registry, and that component is laying in wait, being malicious or dangerous. So that's a specific type of attack when it comes to open source components. And then there's CI/CD misconfiguration. So the problem there is that if a threat actor can compromise a build system or a CI/CD pipeline, they don't have to get access to the source code. They don't have to do any of these other attacks. They can actually modify the build process itself and launch an attack through that build pipeline. And then typo squatting we've already talked about as well. All right, so there is kind of an elephant in the room, which is AI. So let's talk about that a little bit. You would think that AI could fix all these issues for us and we wouldn't have to worry about them, but the fact is that AI actually introduces some new threats, some new attack vectors. AI generated code, you may hear about vibe coding, and that can be vulnerable. In many cases it is. And then malware in an ML model or an LLM can exist. Malware in AI generated code, even learned bias. And then if you think about in real life Armageddon, AI becoming sentient and becoming Skynet and taking over the world and eliminating humans would be the ultimate Armageddon on the cyber side.
Hopefully we're a bit away from that though, right?
Yes, we can hope. Although I have watched some YouTube videos that are a little bit scary in that department. All right, so let's talk about some ways you can defend against the AI dangers. There's a guy named Jim Manico. He's a premier educator in the area of secure coding and secure application development. And he's also a speaker at many application security conferences. But lately he's been commenting and kind of shouting from the rooftops about how AI creates horribly insecure code. And he's, taken steps to help with that. He's built some programming, prompt engineering rules, and these rules help AI engines to generate more secure code and more maintainable code as well. So that's a resource that's available. It's a good example of, being nimble, adapting to the current landscape and adding these security guardrails, especially in a world where non-coders are starting to do this vibe coding to build software, which may not end up well. And then on the next slide, I'm sure most people in the call today or in the webinar are familiar with pickle files, and the problem is that these can introduce malware in the ML models. And so the reason is, pickle is a very popular format for ML models, in the Python ecosystem, and pickle files just serialize data. And when the file is loaded, gets deserialized. And well, it turns out that threat actors, they can embed attacks in those pickle files. And the attacks get executed at the deserialization process. And some bad things that can happen include, executing, spawning processes on machine, communicating over a network, or even executing code, which could be essentially another remote code execution vulnerability or attack. And so what you see here are just some of the policies that our product includes that does the checks for these attacks within pickle files. And so, there are safer formats to use besides pickle, but pickle has been so popular that obviously the bad guys are gravitating to what's popular because they can more likely get their attacks to succeed. So better not to use pickle. If you do, at least run these checks to make sure they're safe. Okay, now the bonus round here in this part of the game is looking, thinking beyond vulnerabilities. So as we've seen, when you're on the Oregon Trail, you can't just worry about one thing. There are many ways to die, and supply chain security, you can't just worry about vulnerabilities. You've also got the malware, you've got tampering, leaking of secrets like API tokens. The malware especially they're often state sponsored, right? So there was the WannaCry back in 2017, but more recently the Salt Typhoon campaign, which I'm sure many of you heard about, the one that it infiltrated major US telecoms like Verizon and AT&T in a persistent way. It's not like they were in once and they got kicked out. They were in a persistent way. So those advanced persistent threats from the state-sponsored actors are always difficult to defend against. And then in terms of supply chain poisoning, SolarWinds and 3CX, they're software companies whose build systems were compromised. And as a result, they released malware-infected versions of their product to their paying customers. That's a really bad day for your company. But also SolarWinds and 3CX customers learned the hard way that, software supply chains, they can be poisonous even through no fault of your own. Companies are probably extremely conscious about vulnerabilities and quashing them all, but in the end, one of your vendors sends you an updated product that's infected with malware, that's something you hadn't considered, right? And then the latest trend we're seeing is malware targeting developers. So there's a constant stream of malicious open source packages popping up on PyPI and NPM and other registries. Now they get taken down pretty quickly, but they're still usually downloaded hundreds, if not thousands of times. And then now the new way to die here is malicious VS Code extensions. So you probably know Microsoft has a marketplace for these extensions, and there's around 60,000 of them today. And really very little is done to check and ensure that they're safe. And so there have been malicious extensions making the news lately. And it's just developers beware, basically, when it comes to these extensions. And we are also going to mention a free resource from ReversingLabs to help in this area as well. And then kind of to wrap up, before I turn it back over to Kadi, so you want to avoid the stampede here with all these different dangers. So, how to do that? Well, there's obviously the tests with the security scanning tools that we've talked about, and automating those in the CI/CD pipeline is important. But even then, like if you're a SolarWinds or a 3CX, maybe you really need to do a final build exam, check right before you release something, scan the binary or the software package that you're about to release or deploy if you're deploying it, and make sure it's not infected or dangerous in some way. And then there's other things as a software producer that you can do to really up your game in this area, things like doing differential analysis. So checking, comparing the difference between version 1.1 to 1.2, what changed? Are the changes I'm seeing expected in terms of what new behaviors are in the software that weren't there before? And is there anything different? Did I see differences that I don't expect, which is a red flag? And then also reproducible builds. Reproducible builds is a solution to defend against build system tampering, where you are comparing, you have two separate and isolated build systems, think CI/CD environments. They're each producing the same software, from the same source code, same open source libraries, same configuration, but they're separate and isolated. And so you end up having two software artifacts at the end of those builds. Software artifact A, software artifact B, you compare those in terms of hashes. If they match in terms of file hash, then they're the same, right? But the problem is building in two separate build systems like that typically does not produce the same hash at the end, because there's differences in things like the timestamps, order of operations. There's various ways that cause differences in the file hash, even though the software is the same. But how do you know if the file hash is different if it's due to an attack or a tampering attack, or if it's just due to those timestamps and things like that? So the .NET build environment has some built-in ways to do the reproducible build checks with the file hashes that eliminates things like differences in time and those things. But our product from ReversingLabs also has some reproducible build capabilities, but it doesn't compare based on file hashes. It compares based on behaviors. So the behaviors of the software, what is the software capable of doing? It compares artifact A and artifact B in terms of those behaviors. And so that's another good defense as well. So I think that covered it. I talked a lot. So Kadi, let me turn it back over to you.
Thanks, Dave. So let's get to the cheat codes, right? Everybody's looking for that cheat code of how to stay on top of things. Is there something easy I can do instead of having to dig through that haystack to find those needles, right? So for the game, I'll be completely honest with you. I don't know if I'm just a bad gamer, but I was like, is there a cheat code in this? Turns out there was, and I missed this. I probably would have done a lot better playing this game as a child. But so thanks, Gemini, for informing me. I learned something new too, that there is a cheat code in this game. But what's the cheat code here? So Dave has alluded to it. We've talked about it a little bit, but we have secure.software. It's a free website where you can actually go and look up those library risks, right? So you're making informed decisions about the packages that you're downloading and keeping or using, right? So these, the communities we support are NPM, PyPy, Ruby Gems, NuGet, and recently we launched VS Code for those extensions that we're starting to see more attacks on. This is a free tool. There's tons of other ones out there. We just have the largest threat repository. So that's how we're really be able to shine on our analysis here. So feel free to check it out, secure.software. It might change your life. Who knows? We'd also love to hear your feedback on it and what you think. So key takeaways here. I hope you guys enjoyed this presentation and had fun with it. At least, understood the trail today and the dangers we've faced along the way. But I think the key thing here, and I like to keep it simple when we're doing these, is that every choice you make matters, right? So make sure you're prepared. Make sure you have the right tools. Collaboration is also key. So you shouldn't be working in isolation. A lot of companies, have silos where operations, development, security don't talk to each other. Really, you should be making some of these decisions together, right? So everybody's going to have a voice on this, and it's going to have a little bit different perspective. But in the end, when you guys are working together, you have a stronger solution, right? And everybody's getting their needs met. And ultimately, you're more secure against facing those bad guys. Lastly, you can eliminate risk, right? But you can't eliminate risk. I mean, but you can manage it, right? And that comes down to being prepared. What does your doomsday plan look like? What checkpoints or fort crossings do you have in place to help prevent a disaster? So I always like to think about it like this. If you wouldn't raft down a river blindfolded, why would you release code that hasn't been checked? Right? So that's it. Here's some free resources we put together. So like OWASP Top 10, everybody should know about that one. Secure.software, as we said, Salsa Framework by OpenSSF is also really good for some of those best practices. So that leads us to the end. Any questions? And thank you for going on this little journey with us for the past 40 some minutes. Oh, William.
So I'm curious what your stats are on where the problems arise, because there are many places in the life cycle that they could arise. They could arise early via some kind of typo squatting. They could arise late because of some sort of compromise to the build process. And of course, checking late is good because you're checking close to the money. But it also means anything that arises first there is late arriving information and therefore more expensive to fix than if you can catch it earlier. So I'm just curious, first off, what the profile of discovery is.
I can take that, Kadi. So yeah, William, I think that the problems occur everywhere. I think most commonly right now, we're seeing it in open source components. I mean, most commonly, it's vulnerabilities that were introduced inadvertently, but more and more, there's targeted malware attacks from the open source. So when you bring open source components in, that's where your project could get infected. Then there's been a big movement, I'd say, in secure development over the past 10 years called shift left, right? Because like you're saying, if you're only checking it at the end, it's really kind of too late. You could have been fixing these things all along the way. And so shift left is very important, and that's been very successful overall. I mean, I think the number of security issues has obviously not shrunk, but I think there's more awareness now because developers are actually checking these things early with tools and whatnot. But I think the bad guys adapted to that. And so that's why you saw something like the 3CX and the SolarWinds, where they went after the build system itself. So they didn't care about what open source components you had. They didn't care about changing your source code. They just wanted to get into the build system. So the end artifact that gets deployed or released, that was infected, and so all the shift left stuff you didn't help with that particular attack. So I think now there's more of a movement to like shift right and shift everywhere, all along the way, because the attacks are so sophisticated now that I don't think you can overlook any of it.
So check early, check everywhere.
Yeah.
Often.
This does raise another question for me. There are several groups that vet open source projects, and one model for that is you set up a proxy and you can only get vetted versions of things, and so you're working with a controlled set of dependencies, and that's fine as far as it goes. But in talking to the people that I've met who are doing that, they all say, well, you can subscribe to this service. We can set up a repo for you. You can do it just based on our reviews. But there's no assurance that this vetting is correct. And it seems to me that this is a general weakness of open source, that on the one hand, it's freely available and subject to a lot of scrutiny from many eyeballs. And on the other hand, it's always disclaimed as responsible for any consequence. And that's very good for developers and for people building that code. But it's not so great for the businesses using that code. I think this means there's an opportunity, a business opportunity, where if you are in the business of vetting open source software, you offer some sort of capped liability for the components that you have vetted, and you can buy that on the back end in partnership with some insurer and then sell it across your whole subscription customer base on the front end. But I haven't seen that model anywhere.
No. I definitely feel what you're saying, because there's been talk about doing cybersecurity insurance for years, and you kind of the way I've heard it equated to is like flood insurance, right? It's great if it happens, right? But more than likely you're not going to have it. So the problem, I think, with a lot of the interest in cybersecurity insurance is it's hard to equate what that dollar amount would be, and I think that's where some of the struggle is equating a monetary value to the risk associated with it. From what
Well, that's true. That's very true if you need to have full coverage of by some measure, right? But if the question is, if I'm running a business using open source and I'm considering subscribing to a service that vets software, I'm not going to expect that subscription to cover my full damages for the software. So the liability could be capped at a relatively modest level. However, that coverage makes the subscription much more valuable to me.
Yeah.
And it indicates to me that I'm not just paying for the privilege of trusting whoever's vetting the software. I'm actually paying for something more than that. They're delivering to me this indemnification, limited though it may be.
Yeah, it's a good point.
Yeah, I can't really speak to the legal or liability aspects of it. I do think that there are some solutions out there, including ours, where you can basically curate your open source packages ahead of time, and then that becomes an approved set of components that developers can use. I haven't seen is that attached to any like liability protection or legal anything like that, but I think there are some tools like that can sort of pre-vet components. Now the issue, of course, of that is like log4j. Log4j, one day this component was perfectly fine. The next day the world was ending because it was somebody found a vulnerability, which is interesting because that was an open source component, and like you would think people had eyes on it and it was safe, right? But for 8 years nobody noticed it. And it was like open source. Yeah, it's like you kind of assume that, oh, it's open source, people can see the code, so they could tell if it's dangerous. And in some cases that's true, some cases not.
And maybe some people did notice, they just didn't tell the rest of us.
That is very possible. That is very possible. Somebody had it in their back pocket and was using it.
Yeah, the constant monitoring piece too.
Yeah.
Clutch. Great question.
Yeah, I think any such system would have to have contractual clause that said something like, if you report the vulnerability or you suffer a consequence before the fix is available or before we have announced that you should take this out of your system, then you're covered, and otherwise you're not covered because you're not damaged upstream from our report that this is bad software and you should remove it.
Yeah.
Great discussion, and thank you, William, for great questions. I have a follow-up questions. Well, we'll start with one. It sounds from this discussion is that closed source solutions might be better from the cybersecurity point of view, and yet we see a big shift to open source. What practices could be implemented within projects, open source projects, that would make them more adverse to cybersecurity threats?
That's a great question. So that would be doing those security checks. So it's running running your package through a tool, right? So it's looking for different types of categories of where risk is involved. So, there are tools out there. We're one of them. We actually do a badging program for open source maintainers where we give away the software for free so you can check your code to make sure that you're putting out there secure code. And that covers things where it's like hardening, tampering, secret leaking, malware vulnerabilities, and I'm forgetting one right now, but there is another, licensing risk. So there's a couple of different things you need to be thinking about when you are developing these projects or actively maintaining them. And what we've seen is a lot of the packages that are secure often will have badges on them. So it's a quick, easy identifier for folks who are using them. So you might see one that says, the OpenSSF scorecard. You might have a little badge in the README file there on GitHub. There's also ones where it just tells you the version, right? So there's a couple of different badges out there that you can see to kind of get a better understanding of the security of the packages, or just kind of where they're at. Is their CI/CD passing or failing? That's another one. So there's a few different things you can do. There's a few different tools. But like I said, if you are an open source maintainer, please connect with me. We'd love to chat with you to see how we can help you, at least give you back a little bit more time and sense of sanity instead of worrying about some of the security things.
Sounds good. I will pass this along to the maintainers I speak to. Well, we're nearly at time, so I would like to thank Kadi and Dave for this very insightful presentation. And I also would like to thank our attendees for being here, for your curiosity, for helping shape this thoughtful discussion. I'll be posting the presentation on the OpenTeams YouTube channel in the coming days. And if you missed anything or just want to relive the highlights of today's presentation, please keep an eye on your inbox. And also, if you'd like to keep the conversation going, please join our public feed on LinkedIn, and I'll share everything in the chat in just a minute.